So now that we have Ptolemy's theorem, I'm going to show you some cool stuff that we can prove with Ptolemy's theorem. In particular, I'm going to give some sum of angle formulas. So I'm going to kind of do like a whole thing. I'm going to first derive a formula for sum of angle for chords, and then I'm going to show you, I haven't done this before, but I'm going to show you how we can translate that to the sum of angle formulas that we have for sine, for example, the sum and difference formulas that we have for sine. I'll leave it up to you to figure out how you can get cosine. Also, my approach here is going to be slightly different than the books, but as you will see at the end of it, it all turns out to be basically an equivalent method. Obviously, I'm using the same techniques and we're getting the same answer, so overall it should be the same. But I just wanted to warn you that my alpha and beta is going to be a little bit different than how the book has things. All right, so let's say this is the center of the circle, and we're just going to draw a diameter. We're going to call this A, and we're going to call this D. And our first angle, this angle will be alpha, and then this angle here is going to be beta. So alpha goes from there to there, and beta goes from there to there. And this point is B, and this point is C. Now, A, B, C, D forms a quadrilateral, and so we can apply Ptolemy's theorem. So it's a little unclear. That's not the point D. Sorry, my circle here is getting a little bit messy to deal with, but I don't know. It was a good circle. I don't want to get rid of it yet. Okay, so then if we think about the quadrilateral, let me go on ahead and fill in the quadrilateral. I'm going to use a green marker to do that. So by fill in the quadrilateral, I mean just draw the legs, so I can have something to refer to a little bit more concretely. That'll be helpful for me. And then the diameter here is going to be that leg. Okay, so Ptolemy's theorem says the product of the diagonals is equal to the sum of the products of the opposite sides. So we've got to look here a little bit to see what the diagonals are. But A to C, that's one diagonal. So by Ptolemy's theorem, we know AC, not equals yet. We know AC times the other diagonal, so that's going to be BD. I'm going to try to put the first letter, just have these, the line segments here listed in alphabetical order. And then this is going to be equal to the products of the opposite sides. So what are the opposite sides here? Well, AD and BC are opposite sides. So this is equal to AD times BC. And then the other opposite sides are going to be DC and AB, or CD and AB. Or dependent all in alphabetical order, AB times CD. Okay, so now what I want to do is I want to write all of these in terms of chords. So we can all recognize these. We can recognize all of these as chords of something. So, okay, what about AC? So AC is going to be the chord from there to there. Okay, but that's the chord of alpha plus beta. So chord alpha plus beta is equal to AC. And unfortunately, my string of equalities here is going to have to be broken up over a few lines. So chord of alpha plus beta is equal to AC. Okay, now what about BD? Well, BD is this distance here. BD is this distance here. And it is the chord of this angle. So again, BD is this distance, and it is the chord of this angle. Well, the angle from there to there is just 180 minus alpha. So BD is chord 180 minus alpha. Okay, so that's the left-hand side of Ptolemy's of the equation in Ptolemy's theorem. Okay, now on the right-hand side, what is AD? Well, AD is just 2R. And BC is that chord right there. That's just chord beta. And then plus AB. AB is chord alpha, because this is AB, so that's going to be chord alpha. And then CD is this distance right here. So it is 180. So CD is chord of this angle right here, but that angle is 180 minus alpha minus beta. So this is going to be chord I don't know why I'm doing that. Sorry. chord 180 minus alpha minus beta. So that right there says chord 180 minus alpha minus beta. Okay, so now what I want to do is I want to translate everything into signs. So remember that chord theta is equal to 2r sine theta over 2. So now I'm just going to translate wherever I see a chord, I'm going to write it as sine. So sine of alpha plus, or sorry, chord alpha plus beta then is going to be equal to 2r sine alpha plus beta over 2. And then that chord, 2r, okay, so it's going to be 180 minus alpha, it's going to be sine of 180 minus alpha over 2. So that's going to be sine of 90 minus alpha. Sorry, parentheses going here. Okay, now on the right hand side we're going to have 2r. And then chord beta is going to be 2r sine beta over 2. Okay, 2r sine beta over 2. And then plus chord alpha, that's going to be 2r times sine alpha over 2. And then finally, chord 180 minus alpha minus beta is going to be 2r sine, and sorry, this is going to be 90 minus alpha minus beta over 2. Minus alpha over 2 minus beta over 2. Sorry about that. Okay. So now I'm going to introduce two new variables. I'm going to say that angle, let's say, angle theta, I'm going to say is equal to alpha over 2. And I'm going to say that angle gamma, I'm going to say that angle gamma is equal to beta over 2. Okay, so what I'm going to do, I'm going to look over here. I notice every single term has a factor of 2r, 2r times 2r or 4r squared. So I can divide by all of those, and I'm going to solve for sine of beta over 2. So sine beta over 2, that's going to be sine gamma. Sine gamma is going to be equal to this, which is sine theta plus gamma, Okay, so alpha plus beta over 2 is theta plus gamma. So this is theta plus gamma. Now, sine of 90, this should say sine of 90 minus alpha over 2. Sine of 90 minus an angle is cosine of that angle. So this is going to be cosine theta. And then it's going to be minus this term right here. So minus sine minus minus this term right here, minus sine theta. And then this right here is sine of 90 minus alpha over 2 minus beta over 2. So that's cosine of theta plus gamma. That's cosine theta plus gamma. Okay, now what we want to do is we want to try to use this. We'll try to use this formula here. This is not the way that the sum of angle formulas is typically presented. So now what I'm going to do is I'm going to introduce a new angle, delta, and delta is going to be equal to theta plus gamma. And if you just write that with this substitution, so again, delta is theta plus gamma, that more or less corresponds to alpha plus beta after we do this over 2 thing, which is how you can sort of translate between what I'm doing and what the book has. Anyways, so gamma, we're saying that delta as a new angle is defined to be theta plus gamma. So then what is sine of gamma going to be? Well, gamma is delta minus theta. So this is sine of delta minus theta. Now over here, theta plus gamma is delta. So we're going to get sine delta. Then theta just is what it is, times cosine theta minus sine theta And then theta plus gamma is delta. So cosine delta. Okay. So now we have this. This is the typical difference of angle formula for sines. Okay. And obviously I'm using here that we know that cosine, or the sine of 90 minus theta, is equal to cosine of theta when we're measuring things in degrees. Okay, now I want to do one other thing that sort of uses some facts about trig functions that I haven't proven, and this is going to be that cosine is an even function and sine is an odd function. And I'm going to bring in a new variable. The new variable that I'm going to bring in is going to be omega. Omega is going to be equal to minus theta. Omega is going to equal to minus theta. Okay, so how are things going to change over here? Well, sine delta minus theta is going to be delta plus omega. And then sine of delta, that just stays sine delta. Now cosine theta, that's going to be cosine of minus omega. Okay, sine of theta is going to be sine of minus omega. And then cosine delta. Okay, but now cosine is an even function, so that goes away. And sine is an odd function, so the minus comes out like this. And now we do have the typical sum of angle formulas that you know. Okay, so I've given the sum of angle formulas. Excuse me. I've given the sum of angle formulas for the sum of angle formulas and the difference angles of the sum and difference of angle formulas, where you have sine on the left hand side. Now typically you're always allowed to invent your own discussion topic. Another one would be to figure out how you can do this somehow to get the corresponding formulas for the cosine of delta minus theta, or cosine of delta plus omega, whatever variables or whatever you want to call your angles. But that's it for this video. It's a use of Ptolemy's theorem, and I hope you found it interesting.